Hi all, welcome to this session on Quadralogics Docker in Action series. So let's wait 2 more minutes for any other people to join in. Let's wait for 2 more minutes. Hope I am audible to all of you. So let's start our session. So welcome all of you to the third session in Docker in Action series from Quadralogics. So hope you are enjoying all our previous sessions. So this is yet another interesting session for you. I am Anju M. Dominic, Principal Consultant of Quadralogics. I will be the trainer for your session. So in today's session, we will be dealing with some of the Docker security concepts. In the previous two sessions, we have seen Docker fundamentals, Docker essential concepts, and how to work with Docker, how to create images, how to do Docker Swarm, how to do the Docker Compose file, how to perform with the Docker Compose file. All these things we have seen. Now let's move to Docker security. Why Docker security is very important? Let's go back to our previous session. Session 1, we discussed about virtualization. So virtualization is a software representation of a computer system. So this is mainly used to save a large amount of space, reduce the cost, and what it does is it virtualizes a number of applications on a single system. It is just like having multiple systems on a single system. And there we saw two virtualization techniques: virtual machines and Docker containers. Take the virtual machines. The main difference between virtual machines and the Docker containers are that virtual machines have an individual operating system and its own applications. But in the case of containers, for example Docker containers, it make use of underlying host operating system. Multiple containers share a single host operating system. So when you share an item, there is always a problem with security. That is why virtual machines are often considered more secure compared to Docker. But Docker has some inbuilt security features that help us to work with Docker. So if you are working on an application which is highly secured, or it is something very important, something related to security, some of the companies often prefer to work with virtual machines, even though they are much costlier and bigger in size and it is difficult to manage with. Some of them still prefer virtual machines. but Docker containers are still the most preferable one due to its ease with which we can work in Docker containers. So compared to VMs, containers are a little more less secure. And what are the other vulnerabilities you can think about while using containers? Assume that you are having multiple containers, say 5 containers working on a single Docker host. What are the main vulnerabilities you can see? Suppose, say you are having a compromised container. Compromised container in the sense some malicious activity is there in that container. If you are running that container, what happens? It can directly affect the Docker host. And if the Docker host comes down, all other containers also comes down. So that is one vulnerability. And other vulnerability is that if you have a root user in a container, it is also a root user in the Docker host operating system. So all the users which are roots in the containers can also modify the Docker host. So all the users which are having root privileges in the container is also root in the Docker host, and this is a serious vulnerability. Because if you have root privileges for a particular system, you can pretty much do whatever you want on the Docker host. And what are the other vulnerabilities? Take an application point of view, that is, you are having 5 containers on a Docker host. Take the first container, say container A. Container A thinks that it is having the entire host operating system to itself. It doesn't know about the existence of the other containers. It is in an isolated manner. So there is always a tendency to the containers to make use of the entire resources of the host operating system. As a result of which, other containers are not getting their enough part of resources. This is often termed as denial of service attacks. That is, one container is making use of the almost all the resources of the host operating system. Then what are the other vulnerabilities you can think of? Consider images. You're downloading an image or pulling down an image from a Docker hub. What if that image is corrupted? Or if there is some malicious activity in that image? If you run that container, what happens? It can adversely affect our Docker host. So these are the main kind of vulnerabilities we have with Docker host. Let's just list down that first. In a notepad, I will just mention the vulnerabilities. And what are the vulnerabilities you can have? First one is a bad container. Second one would be users with root privileges. Then the next one would be the denial of service attack. So this is another kind of vulnerability that we have spoken about. And the fourth one will be bad image. So these are some kind of vulnerabilities that you can find in Docker containers. So how to fix these vulnerabilities? There are many methods. There are many methods to fix vulnerabilities in the Docker containers. There are many inbuilt mechanisms. Suppose if you take the denial of service attack. If you take the denial of service attack, it is like that a container, if container is compromised, it can make use of the entire Docker host operating system. So in order to avoid that, you can fix the amount of resources attached to a particular container. So you can think in such a way that even if the container gets corrupted, only a part of the Docker host will be affected. So that can be done by using docker update command. If you go to the docs.docker.com, let's go to the docs.docker.com and search for Docker update. If you have Docker update command, you can see you can fix what kind of memory or what is the CPU share that you want to have for this particular container. See, there are many options available. Say suppose CPU shares, then number of CPUs, then kernel memory, other memories, memory reservation. So you can update whatever amount of resources that you want for a particular container. So even if that container gets corrupted, only that part of the resources will be affected in the Docker host. So this is the method you can give. Suppose if you take say I'm going to log into my cloud instance, say I'm going into root, I'm going into my cloud instance Docker training 20, and if I see some Docker images, I can see so many Docker images. So let's say I'm going to run a container, say docker run. I'm going to give a name to the container, say I'm going to run the Jenkins container, and then I'm going to Jenkins 1, I'm going to name it as Jenkins 1, and I'm going to run the Jenkins image. So if you run that, what happens? So it is running the container now. Okay, sorry, ideally I should have run in the detached mode. Let's see if it is coming out. Sorry, let me take another terminal. ps docker remove this container with the ID 58. So I just removed it, and I'm going to run this again in the detached mode. Run docker run st in the detached mode. So this Jenkins container is running, so I can give an update command like docker update, say CPU shares to be 512, and I'm give the name of the container also. Jenkins 1. So that is how you can set the memory or the CPU or some resources for our container. So in that way only we can limit the effect of a container on the Docker host. So that is one kind of fix. So if you go to our notepad and write that down, So I can use the docker update command. Now there is another mechanism called namespaces. Namespaces. What are the namespaces? Any idea about the term namespaces? Namespaces are just like a surname to your name. That is, it will help you to identify the particular function or a variable because it uses a area for that container to have all these details set. So each container, whenever a container gets created by running the docker create command or docker run command, a namespace will be allocated for that particular container, and all the related processes, all the socket details, interface details, everything will be there in the namespace. So other containers can't make use of the processes or sockets or interfaces of the other containers. So if you have two containers, container A can't make use of the processes or the interfaces or the sockets of container B, because all these details would be in the container A namespace, and all the processes, sockets and interfaces of container B would be in the container B namespace. So that is an inbuilt mechanism that is there in Docker to provide a security. So that is the first security layer in Docker containers, namespaces. Now there is another something called as control groups. If you go to control groups, so as I said before, if you have a root privilege in a particular container, you have the root privileges in the Docker host also, unless it is otherwise specified. So always we can give a user, you can give only limited permissions to a particular user in a container. So even if he has some permissions put run in the container, he won't be having the root privileges, so that he won't modify anything in the Docker host. So that is a type of inbuilt mechanism in Docker which is known as control groups. So there is something called Linux control groups that is mainly used for Linux Docker containers. So, and the other important feature in Docker is Docker Content Trust. Docker Content Trust. Docker Content Trust is a service which is inbuilt in the Docker installation itself in these days. It always verifies, authenticates and authorizes the Docker images. So that is, if you have multiple images, you can find different kinds of images in the Docker Hub. Some are from official sources, some are just like people like us made the images and they have shared it online. So if there is always a possibility that we can we will use a malicious image or a image that is not official. So there is always a chance. So that is where the Docker Content Trust comes into picture. If the Docker Content Trust is enabled, it always checks for signed images in the Docker Hub, or verified images, or the images that are signed by the particular user, and we can verify the authorization of the particular user in the Docker Content Trust. So if the Docker Content Trust is enabled in the Docker containers, only the images that are consistent with the Docker Content Trust will be shown to us. So let's do a hands-on with Docker Content Trust. So before that, you need to understand that Docker Content Trust works on public key infrastructure. That in the sense, it make use of the public key of a user to identify the image, and it also verifies the private key. It also make use of the private key. So when you enable or when you generate a key in the Docker Content Trust, there are three parts to the key. First is the root key, which is basically for a root Docker Content Trust, and then you will have a tagging key, which is respective for a particular repository, and then you will have server management key part, that is just like for timing informations and all, it is managed by the servers. So if you have the root key, root key can generate the repository key, and with the repository key you can sign the images. So whenever you push an image to the Docker Hub, you can actually sign the images and push it to the Docker Hub. So whenever you pull down an image from the Docker Hub, the signed images are verified by using Docker Content Trust. Let's see how to sign the images and verify the images, or verify the signed images. So if you go to the terminal, by this time the terminal would have timed out. So let's see, it has timed out. So let's close this terminal and go to another terminal. SSH root at Docker training 20. Sorry, this is not 0, this is 20. So Docker SSH root at Docker training 20. So here I am going to export or enable the Docker Content Trust flag. So before that, let me see if we're having any images. I have so many images. So let me take, I take this voting app image. So already I am going to voting app image. So I am going to tag this voting app image. So Docker tag, I am going to tag the voting app image with my voting app image. I will tag it in such a way that it includes my Docker Hub username and the latest tag. So Anju Rose voting app latest. Now let me just export the Docker Content Trust variable. So if it is enabled, that means the Docker Content Trust is enabled in this terminal. Docker Trust is equal to 1. So I have exported it. Now let me just pull the or push this image to the Docker Hub. I am going to do that in the debug mode so that you can see how it is getting pulled. In the pull, you will give the name of the image. What is the image name? Voting app and latest. So let me see what happens. It is reading the certificate. It is showing does not have trust data. So let me see if I have any errors in my commands. So it is pushing it to the Docker Hub. It will take some time. So now it will ask for the root key. So yeah, for this particular repository I need to specify my root key. I'll be specifying my root key here. So repository key, root key is verified, and now I need to give the specified repository so key, because I have already generated and giving the keys, but you can actually generate it by using key generate also. So now I have signed the voting app image, and let's see if it is signed. Docker trust inspect, Docker trust inspect, Anju Rose voting app. It will take some time to show the details of the cSigners report admin. So this is a signed image you have pushed into the Docker Hub. So if you take Docker, again the debug mode, and I'm going to pull this image, Anju Rose voting app. So it will verify the only if it is successfully verified the targets, it will verify the user, and it will show the sign that it is verified. Since I have already have the image, it is telling us image is up to date. Now if you want to revoke the you signed image, you don't want to sign that image once again, so you can use the command, I think, docker trust. If you give -help, you will be able to see the different commands. So there is remove trust for an image, revoke. So I'm going to do that. Docker trust revoke, and I'm going to give my name of the image, voting app. You like to delete all signature data for Anju Rose? Yes, I want to delete all the details for this one. So it will delete all the sign and the passphrase for repository key. Again, whatever repository key I have provided before, I need to give that once again. So 4 bots successfully deleted the signature. So if you again give docker trust inspect, you will be able to see there won't be any signers now. Let's see that. I think I forgot to zoom it out. Hope it is clear to you. So what we did was we signed it our Docker container. After that we tried to push it down and verify it, and after the verifying I just did the Docker trust inspect. I could see that I have the repo admin signers here. After that what we did was I pulled down the Docker image. It got verified with who I was, and see, and then after that I wanted to revoke that signed image. So what I did was I used the docker trust revoke command, so it will actually revoke the signed image. So here the signers are none. Before signers was the remote admin. So here it is now signers empty. So that is how you work with Docker Content Trust. If you want to know more details about the Docker Content Trust, you can go to the docsdocker.com and search for the Docker Content Trust, or you will be seeing many information about the Docker Content Trust. If you search in the net also, you will be able to see how the Docker Content Trust works. So that is an important mechanism about the images. So if you go to our notepad, we These are the some of the inbuilt features for the Docker containers to fix all the vulnerabilities. But this we had for a single Docker host. But when it comes to the Docker swarms, you have but multiple Docker containers, so multiple Docker host. So there also the security comes, it is very important there also, because one Docker host, if it communicates, or if one Docker host is compromised, the entire application would go down. That is, we would have arranged in such a way that different components of the application will be working on different Docker daemons, and if one of them goes down, it affects the other Docker host in the Docker swarm. So mainly what we do is that in the case of Docker swarm, we will have something called root certificate authority. So whenever a swarm get initialized, yesterday we saw about the how to initialize swarm and how to go about with services in the swarm. So whenever a swarm get initialized, it will create a management token and also a worker token, and each token will have details, a digest of the root CA certificate. That is, whenever a swarm get initialized, a new root certificate authority is getting created, and the token will have a digest of the root CA certificate and also a secret. So whenever a new node comes into the swarm, you will be either adding it as a worker node or a manager node using the worker token or the manager token. So what happens is that the joining node make use of the digest of the root CA and identifies the remote node or the leader node where the Docker swarm is initialized, and Docker remote host will identify the new node with the help of the secret component in the manager token. So that is how it works. So if you go to a Docker swarm, let's create a Docker swarm. So I will exit this terminal, so I don't have this terminal now. Let's close this terminal. So let's go to another terminal and log into my Docker master cloud instance. So I will just increase the size in case if you are not able to see it properly. So here I am going to log into Docker master and I'm going to initialize a Docker swarm. So I will use Docker swarm init. Docker swarm init. Now let's go to the another terminal and log into my another cloud instance. Let me check the and increase the size also a little bit. So this is the node 1. I am going to log into root at Docker training 19. So I'm going to log in there and I'll take this command. So I'm going to join it as a worker node. So I'll take this command, copy it, go to the other terminal and run it. So the node has joined the Docker swarm. So if you give Docker node, you will be able to see the Docker nodes in the container. So we have the containers ready now. So now let's see if you can go to the other another terminal and go to my another instance. So I will use this one. So terminal to SSH root at Docker training 20. So if you initialize, so let me just add that also as the worker node. So let me just add that also. So you will have two Docker nodes added to the SWAM. So Docker node ls. So if you want to see the certificate or root CA certificate, you can see it by Docker SWAM CA. So it will show the certificate which is important for security purposes in the Docker SWAM. So you can actually rotate the certificate if you want. Rotate in the certificate if some of the nodes go down, that if the leader node goes down, we can actually rotate the certificate. Rotation of the certificate means that all the nodes which have been trusting the old root CA will now trust the new root CA that will be created by the consensus algorithm, and you can rotate the certificate. So you can use the Docker SWAM CA rotate to rotate the certificate. So all the certificate associated with all the nodes will be changed. So that is how you can work with root CA architecture in the Docker SWAM. That is another important security feature to actually that certificate is mainly used to authorize and identify different Docker nodes in the Docker host. So that is one session, Docker SWAM. Now let's go to Docker Enterprise Edition. So till now all these features were added in the Docker Community Edition, but if you go to Docker Enterprise Edition, usually instead of using Docker Container Trust or instead of using the Docker Hub, it mainly uses the Docker Trust Registry, which is also a repository for storing all the Docker images, and it make use of, suppose if you want to have a cluster management in the Docker Enterprise Edition, we will use UCP or Universal Control Plane in Docker Enterprise Edition. So that is the main additional features in the Docker Enterprise Edition compared to the Docker Community Edition. And in the case of Docker UCP, in the UCP, you can do you can limit the access to different users by using role-based access control. That is UCP is just like a Docker SWAM in the Community Edition. So you will have multiple Docker daemons or multiple Docker daemons running on multiple Docker hosts. So there you will have many number of users. Say if you are working on a particular project, you will have a development group, you will have a business group, you will have the operations team. So development team only needs to modify some part of the code, operations team need to manage all the infrastructure and details like that, and the business team only needs to view certain details. So you can give specific access to this kind of users in Universal Control Plane using role-based access control method. So this is how you limit the accesses given to particular users in the Docker Enterprise Edition. This actually helps us to work with users with minimalized root privileges, so that all the users will not get root privileges. That is why we do this is mainly because if you get root privileges in a container, you get the root privileges for the Docker host as well. So you can specifically decide the access types that you want. You can have full control on the all source code and application. You can have limited control. You can have only view control of different container applications, etc. So that is something related to Docker Enterprise Security. So that is the main security concepts that I need to discuss for this session. So Docker containers are having many type of Docker vulnerabilities, and we can fix, there are inbuilt mechanisms that help us to fix the Docker vulnerabilities. So let's go back to the PPT and see what is the next thing that you need to understand. So the next important thing that you need to understand in the in Docker security is that there are some best practices that you need to adopt while writing or while creating Docker images. The first thing is use minimal based images. In the yesterday's class, we just saw that I think the first class we wrote a Docker file to create an image. So one of the base images was what we used was Ubuntu. So if you use such big base images, that images will have some inbuilt vulnerabilities. So if you access that base images, you are also including that vulnerabilities in your container. So always use a base image that is very minimal in nature, and always specify less access to a user in the containers. You can specify user for a container in the Docker files. If user is not specified in the Docker files, take it to be as root user. So there is a keyword called user that can be given in the Docker file to denote a particular user. So if the user is not provided, Docker file assumes that it is the root user. Then always use the Docker content trust for creating all the images. And there is some other method that is something called as Docker ignore files. Suppose if you are having so many files, suppose you are having a Docker file in your root directory, you have so many source code files and so many other files also which are having some sensitivity, some sensitive informations. So when you create an image, when you build an image, there is something called Docker context. So if you take Docker context involves all the files that get tarred into the Docker image. So if you have a Docker file kept in your root directory, and if you give a Docker build command, actually all the files in the path where you have the Docker file is getting compressed into a tar file, and it will be uploaded into the Docker image. To avoid that, you can always use Docker ignore file. So Docker ignore file, so whatever pattern you have mentioned in the Docker ignore file, all the files starting with that pattern will be discarded. So it will not be taken for creating the tar file. And the another type of best practice that you need to practice in Docker image is that always use copy instead of add. So copy and add instructions are very similar to the Docker file. So if you go to my previous example, if you go to my Docker that is GitHub, and if you have the web application that we have discussed in the first session, you will find that you will have the copy instruction here. So where you actually copy your source code from the destination to the container space. But instead of, there is also one another command called add instruction. So instead of copy, you will have add. It also does the same thing. It copies the files from some other place, from a source to a destination folder. But only thing is that in the add command, we can also use URLs or tar files, that path. So if you use a URL, there is always a chance to have some man in the middle attacks. That is, you are actually transferring a tar file or URL to the image. So always there is a chance for adding unwanted details or man in the middle attack. So that is why it is always preferred to use the copy instead of add instructions in the Docker file. So that is the best practices for the Docker image. So that is almost all the important aspects that is about the Docker security. So now let's go back to a recap of Docker in Action series. So what we have just seen is that in the first session we went through an example called web app, where you had your source code in the webapp.py file, and then you created a Docker file that will actually have the container that have all the instructions that you need to create an image for your application, and this image could be pushed down to the Docker hub. So that is the main chunk that we have discussed in session 1. In the session 2, we went through this Docker compose files. So if you go to the Docker Compose file, you could see that you can simultaneously make multiple containers active. That is, if you have an application which is having 5 components and each of the 5 component is working on a different containers, you can actually link these containers together and make this active simultaneously by using Docker Compose file containers. So Docker Compose file. So Docker Compose files are mainly used for multiple containers in a particular Docker host. So then we saw Docker Swarm. So you created multiple Docker hosts and we used services to deploy multiple containers to multiple Docker daemons. So that is what we discussed in the session 2. And now let's we have some time left, so let me just take you to some of the important interview questions. So I have some list here. Let's go to my drive. So first I will just check with the normal ones. So if you go to the first set of questions, let me see what is the first set of questions. So first set of questions, so you can very well be asked about what are containers. Containers are where your applications and all your dependencies and configurations are packaged into. This will actually abstract the infrastructure part from your applications, and developers can now concentrate on how to develop an application rather than how to run an application in different computing environment. Second question could like, why do we need containers? As I said before, to abstract the infrastructure part, to maintain a considerable consistent isolated environment. Then also we can actually since all the dependencies are packaged into the containers, we have something called as infrastructure as a code also. So now what are the difference between the virtual machines and containers? Main difference is that virtual machine has an individual operating system compared to containers which make use of the underlying host operating system, as a result of which VMs are considered to be bigger in size, and it takes more time to boot up compared to containers, and it is very costly compared to containers, and you have a management overhead also with virtual machines, and you will be able to see mostly these are all higher cost markers. So container now on a Docker host is considerably less compared to number of the containers that we can have on a host is considerably larger compared to number of VMs that you can have on a Docker host. Now what is a Docker? As I discussed before, it's a container platform developed by Docker Inc. in around 2013. So it will help us to test, deploy and manage the Docker containerized applications. Now can you specify some of the other container platforms other than Docker? You will find something called CoreOS RKT, so you don't have to worry too much about that. Just understand that there are other container platforms also, but it is only like most of the container or 83% of the containers are Docker. So mostly used container is Docker. So if you understand the containers, Docker containers, it will be sufficient for you. So you will other Docker container platforms are CoreOS, Mesos Containerizer, etc. LHC container,izers, and Docker containers are actually based on this LHC Linux containers. And why Docker is often chosen compared to other container platforms? It is mainly because Docker is an open source platform. It has a great community support. You almost find good documentation and all the details that you want to work with the Docker in the documents. So and there is no container limitation on the Docker. So the number of containers that can work on a Docker host solely depends on the size of the Docker host or the resources of the Docker host. The Docker does not specify any container limit, that is like a maximum number of containers you can have in a host. Docker does not specify that. And then you have always Docker Hub. Docker Hub is an image repository where you can find all the images from the official sources and also from the other people or organizations, so which we can actually use in your application. So that is edge for Docker container platform. And Docker is actually supported by almost all of the cloud platforms like Google Cloud Platform, AWS, Azure, etc. So that is why Docker is often chosen before compared to other container platforms. So you can, what are the main actions that can perform on the container? You can create, run, stop, pause, unpause. There are so many commands. If you go to the docsdocker.com, you will be able to find out all the commands. Now, another question is, what are the disadvantages of the Docker? Main thing is that Docker is not fast as the bare metal servers, and also even the Docker is an open source container, it is some third party tools are not consistent with the Docker. That is some container or some services, container as a service platforms from Red Hat, that is OpenShift, which is a container as a service platform. Red Hat only works with Kubernetes. So that is, there are some issues like that also. And also one other advantage is when you exit the container, the data will be lost. So if you want to persist the data in the container, you have to use for volume mounting. Otherwise the data in the container will be lost. And mainly we make use of the command line interfaces to interact with Docker containers. We don't actually have a GUI, so that is a limitation when you use the Docker. And also compared to virtual machines, it is considered less secured compared to virtual machines. So these are the main disadvantages, like there is a data loss, there is some integration issues, then Docker is not so fast compared to the bare metal servers, and VMs are often considered more secure than the Docker containers. So what is a Docker image? We have already seen it's a readable template having all the instructions to create the Docker image. So you can very well go and see the commands in the docsdocker.com. Now in the Docker architecture, we have seen that Docker client is there, Docker daemon is there. Docker client is where you run the Docker run command or build command or all the commands, and after it is run, Docker client will send the API request to Docker daemon, and Docker daemon will actually manage and control all the containers and images. And if you have a newly created image, you can push it to the Docker Hub, and also we can pull down images from the Docker Hub as well. So that is the Docker registry. That are the main components in the Docker. So we saw about the Docker Swarm for the cluster management basically. Then so when you use the Docker Swarm, it is by using the service feature, it is very easy to deploy multiple containers in the Docker Swarm to multiple daemons. So we have seen about the developer workflow, that is how you create the image for a particular application and do it to the Docker Hub. Now the next, what are the Docker files? You have already seen what are the Docker files. Then what are the Docker Compose files? Very well, you have seen that. Then what is Docker volume mounting? We have performed example of Docker volume mounting with the Jenkins server in the session 2. You can very well go and check that out. Then so that is the intermediate questions. You can have some advanced questions also. just like what is the difference between the add and copy command. So main thing is add, we can give a URL also in addition to the source destination and the target destination. So security features, you have namespaces, all the vulnerabilities you can specify. Then spam mode, like what is the root certificate authority, what is spam mode, public infrastructure, that is actually how it works with the root CA certificate. And then you have what are the basic instructions used in Dockerfile, how they differ from each other. So how, like you have the run instructions to execute the shell commands. CMD instructions are actually the having the arguments that is provided for the entry point instruction. Entry point instruction is actually the first instruction that gets executed when a container starts running. So you have the add instruction. So here the source could be any URL. The source part could be any remote file URLs and any directories or anything like that in the add. But in the case of copy instruction, the source could only be files or directories. It cannot be a remote file URL. So that is the basic difference. And the working directory, it will specify the actual workplace for all the other commands. So I told you about the Docker contents. What are the Docker contents? Is a set of files located in the specific path or URL where you have the Docker file. So it get attached to the Docker image automatically. So if you want to avoid that, you have to use .docker ignore file. And Docker build cache is how to work with Docker build cache. Docker build cache is something where you will have, if you have a build, you will have a cache of that build kept for the next build. That means if you have no changes for any files, already built image would be reused. The image will not be reused if what happens is that so after the parent image is okay. So if you are going to build a Docker image, it always starts from a base image. So that base image will have a identifier. After that you will add next instruction. So next instruction will be an additional layer on the base image. So the Docker build cache always goes and checks for such kind of an image ID that is created with the same instruction. It goes and checks out that if the same instruction image is found, it will be reused. Otherwise it will, entire build will happen once again. So that is the basic difference. That is the basic Docker build cache. Every time when you build, it does not get built from the scratch. It most of the places it reuses the already built cache if there is no changes. So so you have seen about the networks in the Docker Swarm. Mainly you have the Docker network create. Basically you have the overlay network. So that is the basic questions you have for the Docker Q&A. So hope you had a nice session today. So let me just, if you have any. Okay, so you can very well go and see. So actually you can go out. We will be having these questionnaires in our Quadralogics site under the blogs. So you can very well go and see. It is not updated yet. So when we update it, you will be able to see the questions, interview questions also. So that is all for the session. So always give your feedback so that we can improve ourselves. Give the feedback to anjudominic@quadralogics.com, and always feel free to tell us what kind of courses you want, what are the modifications you want in our courses, so that we can improve ourselves and give you a good experience. So that's all for the session. Thank you very much. Tune in for other interesting sessions again. Thank you very much.